So yeah, so here's the TF transform section. This section went a little over my head because I don't know anything about Apache Beam. Does anybody know anything about that? Apparently, Apache Beam is some kind of system that allows you to load large data sets across multiple machines and so on to parallelize your tasks. So when he talks about Apache Beam, I'm kind of left in the dust. I don't know what he's really getting at here.
Yeah, Apache Beam is same as the Google's data flow. It's a kind of workflow orchestration tool.
Workflow orchestration tool. Okay, well, I don't know Google's tool either. So maybe this is Victor, right?
Yeah.
Yeah. Could you explain a little bit about how these things work?
Yeah, I'm not that much into it, but I basically I just study because I'm an infrastructure guy. So yeah, so you think about Kafka, Flink, all those messaging, data flow, orchestration. Basically, you move. Think of just moving data from one place to another using either batch or real time. So Apache Beam is just one of this tool.
Is it? Yeah. So someone?
Yeah, go ahead.
Yeah. Anyone who knows? First, I just wanted to ask Victor: is Apache Beam currently the method of choice to do parallel processing and stuff?
I won't say so because there are all kinds. Like if you use Spark, then Spark has its own streaming process, its own yeah, and in the Kafka is the most. It's different, I guess. Yeah, I said I just know about it. I haven't looked at it, but yeah, Apache Beam just basically is the real time data flow. Yeah, so you can basically process data as part of the data when the data flow from like data capturing to database. You can use this workflow to capture the data and process data, transform the data, and then feed the different machine learning engines.
So this works with online data problems where data is streaming in and is being processed sort of in real time.
Yes. Yeah.
Thanks for that. Does anyone else that's on this call know anything about this? Can add anything to that? What Victor's told us?
Yeah. So Apache Beam basically it's Beam has the first of all it does the transformation. So transformation in the sense when we convert data from one part to another. In a simple word, let's say if you're doing an ETL, extracting, transforming, and loading. So you're taking data from one part and then doing some transformation and then pushing it to the target. Now, the capability of the Beam is that it can take the data from a batch or from streaming. So it doesn't distinguish between the two. It can take data from anywhere. So that's the one thing. And it can scale up automatically. So in a sense, let's say if you have both sources coming in or you have a humongous amount of data coming in, so it can chop your data and then send it to smaller workers. That worker can be spanned for thousands, and then it can collate information from those workers, those transformation, and push it the final results. So scaling up and down is done automatically by the Beam itself. So all you do is just call the API, and you are concerned only with the transformation which you want to apply to the data. You're not concerned from where the data is coming in, and you're not concerned with what the scalability of a processing is going to be. So you're focused only on the transformation part, and that's how it works, the Apache Beam.
Okay, so it makes the whole parallel processing and and moving of data, as Victor was telling us, it makes that transparent to the user, and all you have to do is use that framework and tell it what transformations you want it to apply to the data, and then it takes care of all the rest without you worrying about it. Is that
That's correct.
fair to
That's
say?
correct. That's correct.
Okay. Interestingly, it didn't show how Apache Beam was used. It didn't give any examples of the actual commands that you would use to process the data with Apache Beam. So that didn't help me to understand. But anyway, thank you. That really helps me. I hope it's helped everyone else too. What I zeroed in on this section was where it says that by pre-processing your data before the training, you avoid the need to process it every time you're going through an epoch. So that makes sense to me. If the pre-processing is included as part of the training, then when you train, typically you're going through a number of epochs, and so you would have to process the data. Say if you're going to do 5 epochs, you'd have to pre-process the data 5 times, one for each epoch. Whereas if you do it beforehand, you only have to do it once. And I guess that's the thing I zeroed in on in this section.
So that kind of depends on the pre-processing or transformations that you're planning to do, right? Like if you're doing data augmentation, you would want to do that on each epoch. Whereas if you're doing like normalizing and standardizing, which is going to be consistent across the epochs, that should be fine to pre-process and like do it just once.
Mm-hmm. I see. But so when you do augmentation, couldn't you just generate all the augmented data beforehand and then pretend like it's part of your training set during the training?
Like for example, if you're doing something like rotation, you could pre-compute and say you would rotate everything, let's say 30 degrees or some random value between something. But then on the next epoch, if you were to do it on the fly, that rotation would change. So it's be like your data set is, your model is looking at a new image, right? Rather than looking at the same 30-degree turned cat, you'll probably look at as the same cat, but now turned at like 10 degrees. So it should look like a new image to it.
I see. So what you're saying, Rikhil, is that in some instances you want to do pre-processing in every epoch, and the example you're giving is when you have to do data augmentation.
Right. And that's what I kind of took from that piece that you just read. Whereas stuff like standardizing and normalizing, which irrespective of, I think, data augmentation or anything of that sort, is still going to be like 0 to 1 or -1 to 1. So that can be like kind of pre-processed and held.
The other reason to do it on the fly lazily is also because if you don't necessarily want to store all the augmented images, which is what you would have to do if you did it beforehand. So the lazy processing, which for example FastAI does, is for images, whereas for tabular data you would probably want to go this kind of batch processing mode, pre-process, because you can write it back to the same thing and not store copies and stuff. So that's where the difference lies also, is you may not want to store a whole bunch of things, then you don't do it this way. But if you are okay with tabular data just overwriting whatever data you have and stuff, then you would probably do it, do pre-processing like it's shown here.
Okay, that makes sense. Okay, so let's see.
One question I have is, so Rikhil mentioned about the augmentation. So are we saying that augmentation changes for every epoch? So every epoch will have the example he was giving about 30 degree. So in a sense, are we saying for every epoch we want to have for a first epoch is going to be 30-degree rotation. In the next epoch, we may want to have a 45-degree rotation?
Exactly, yeah.
Okay.
So in theory, you basically have like an infinite data set, because you have all these permutations and combinations possible. Lighting can be any value. Contrast you can set to something. Rotation can be set to something. And then when everything just kind of interacts with each other, you pretty much have like an infinite data set.
Okay.
Yeah, and that makes sense. I mean, I was thinking that, oh, well, why not just do all the augmentations beforehand? You know, let's say you're going to run five epochs. Well, you can just run 5 times as many augmentations or whatever, and then if you have enough room to store it, then why not? But then that falls short if you have streaming data, right? Because the data can be changing, and and then there would be different, as Rekil was saying, there would be different combinations possible with the new, if there's data drift. So, yeah.
True. And just to add, I think so. It also depends upon the your GPU memory. So if you have an 8 gigs of GPU, so that VRAM, it also depends upon that, and the number of the batch size of an image. Suppose you are taking a 128 cross 128 image, and you're trying to pre-process it all, and then trying to save it and then perform computations. So sometimes it's beneficial to have those pre-processing tasks done through the CPU threads, and then ship it off the final, suppose those 64 images in a batch to the GPU, fill up the VRAM, and then perform those deep neural network computations so that everything is down on that particular GPU.
Yeah, I see. Yeah, just to add to that, I the way I've been doing it is, say I have a data set of 125,000 images, right? Um, I want to resize. I want to use images of size 256 or sometimes 512. Then I would do the resize offline. Like resize everything to 256 or 512 or 768, and keep the resize data, but then still do all the augmentations like how it's been described here and how Raquel was saying. Just do it, but only the resize step is offline. I find if I it's like your GPU is just waiting for the data. Otherwise, if you try to resize, I haven't found a good way to like make it resize on the GPU. But yeah,
Because
just
GPU needs everything of the same size for it to be most effective, right? So
right,
you would
right.
lose if you don't resize, and in a way that's what Jamie recommends too, is resize outside, meaning
Right.
on the CPU, and then you are good to use the capabilities of the GPU, because now you have
Yep.
everything of the same size.
Okay. Yeah. I see. Okay. I didn't know he also recommended that. Yeah.
Yeah.
Basically, resize before you start training. Yeah, and
Yeah,
then
once
then train.
resize before batching, right? Because batches have to be of the same size and stuff. So anything he does in his FastAI2, especially, he does a lot more stuff on the GPU, but that's enabled by resizing on the CPU.
Okay.
And then using a batch processing, meaning running everything on GPU.
Well, what about this prefetching thing where they showed how you can you can utilize the dead cycles on the GPU to do stuff while it's waiting. And couldn't one of those things while it's waiting be to do the resizing on the GPU? It's just a question. I don't know the answer.
Yeah, will have to go back, but I thought even in the pipelining, he was actually talking about pipelining stuff on the CPU to keep the GPU fed to its capability. So the prefetching and other stuff that is happening in that diagram, if I recall, it's been, but is happening on the C, as in central processing unit. And then in order to keep the processing, meaning just the numerical processing on the GPU going at full blast.
So here's the diagrams, right? Is everybody seeing that?
Yep.
Okay, so let's see.
So
Wasting
you can see
GPU
that the
cycle.
prepare and all that is on the CPU.
Right.
And once you've prepared it, then you feed it and keep the GPU going at full utilization.
I see. So yeah, so these pre-processing things are being done on the CPU then.
Right.
Okay.
Quick question on the resizing stuff that we were talking about now is, so if you have images of different sizes, you can't throw them onto the GPU. So you need to resize them to some standard size on your CPU, and then you can batch them off, right? Question is like, it's a very specific bit that I kind of encountered was, I first resized them to 1024 by 1024. So that's done on the CPU. And now, because I want to do a lot of experiments quickly, I want to bring it down to, let's say, 128 by 128 or 256 by 256. Since everything is 1024 by 1024, can I throw that onto the GPU for resizing since they're all the same size?
Should be. I don't see why not.
Okay.
Because ultimately what determines it is just the dimension and it's just numerical processing, right? Resizing also is, so one, yeah, if you're standardized, then going down or up either
From
way,
that.
yeah,
Right.
should be
Okay.
possible to do in GPU.
Cool. Okay.
Okay. Any other comments on the first section? Okay. Then he talks about this TensorFlow datasets project, where you can download existing datasets for your experiments, like the the ones that a lot of people use are MNIST and Fashion MNIST and ImageNet, and I think there are other ones too. It's not bundled with TensorFlow, so you have to install it using pip, but I think that's taken care of in the notebook. And then you can call the load function, and it gets that data set for you. I think Jeremy's taking care of things like this in FastAI as well, right? You can download common data sets that way as well. Let's see. I'm sure that PyTorch has similar options.
Sure.
Yeah.
One of the key points is in the notebook, which I'm sure we'll go through. If you list out, he has a line there that lists out all of the available data sets, and it is long. It's a very long list.
Is that near the top or
go up a little bit? Don't go up too far. It's in the
Okay.
TensorFlow dataset section.
TensorFlow datasets section. All right.
One more block up above the exercises.
Okay. Right. Fashion MNIST.
Okay, keep going up. Keep going up.
Keep going. Okay.
A little bit more. Just a little bit more.
Okay.
Okay. There you go. 136.
Aha. Okay.
If you can make that, if you can, what do they call it? Word wrap?
Yeah. How do you do that? Let's see.
But even if you scroll, as you can see, there's a Higgs boson data set.
Jeez. Okay.
Everything. And I used to think Azure provided you with a good
There's
set.
Amazon. Bear robot pushing. Oh, they even have robot data sets. Big
Caltech 101.
Caltech MNIST. Binary alpha digits. Caltech 101. Caltech birds. Cars. Cats, dogs.
Yeah.
CFAR. That one we know about.
Yeah, I'd be interested if there's any healthcare data sets here.
Cityscapes. Well, let's keep going. Maybe there is. Cityscapes is recognizable.
I saw one about CheckSpot, which is the chest X-ray one. I think Joseph just passed it. Yeah.
Did I pass it? Okay. HI. It's before. Oh, there it is. Yeah.
That one.
Yep. So that's a medical data set, right?
Yeah.
Chest X-ray. I guess there's a lot, and they may be adding to it all the time too. Wow, there's colorectal histology. That's another medical data set. COVID-19 cause. Wow, there's a lot of stuff. Breast cancer, breast imaging.
The link, and it's on the TensorFlow documentation site, their catalog, and it actually breaks it out by categories. So there's audio, image classification, object detection, question answering, structured data sets, which has the Amazon US reviews, forest fires, genomics, German credit numeric. I wonder if that's the wildcard data.
Let's look at this. Oh, catalog.
Yeah, that's the one.
Okay.
There you go.
Okay. Data sets, usage, all data. Oh, they have audio. They even have audio data, a whole bunch of audio data sets.
And they have video. A lot of focus right now, if you guys work with video data, applications of video data processing is commercially very, there's a big market for it.
Wow. So this is, Srinivas and the Kaggle group would be interested in this one, right? They have the object detection data sets also, and also the question answering data sets too.
And, for self-driving cars, there's a Waymo data set. You just passed it.
Yep.
And
wow.
For text, you've got the Reddit data, which is there was a recent paper that has healthcare implications. If you can predict from people's writing, you know how we do analysis, can you predict when somebody is depressed?
Yeah.
Those sorts of things. The Reddit data set is actually quite useful for that. As well as, and then there's scientific papers, but more importantly, if you're doing self-driving cars, I think I saw Waymo data set.
Yes, yeah. And there's that Higgs boson data set. So it's physics data, but it's in a table. It's in tabular form. So it would be relatively easy to process, I guess. Wine quality, I'm seeing that data set. Summarize. Reddit, is this the Reddit, the text, the data set you're looking at, you were referring to?
Okay. That's the one.
We even have scientific papers.
And I clicked in on the Waymo data set. That's 336.6 gigs. If you think each of these scientific papers, I've got a downloaded data set of for abstracts. That thing is like 20 gigs.
Wow. Well, at least that's something you could actually put on a normal laptop. That would be interesting. I know people are putting together NLP programs that can read a scientific paper and actually summarize it, which would be really useful. Or even and I guess I've seen services online where they try to do the same thing with books, like you give me a summary of this book, in several paragraphs, and they try to do that. I don't know how good they are.
They're reasonably good. They've been around for a while, just to get a précis of something. And globally, that's in different languages have their own different models. But it is the thing with people don't really download the data set. You guys tell me otherwise. The idea is you build applications with the workflow and so on. The discussions that we were having earlier, whether you use Apache Beam or so on, you'll have streaming data. Or even if large data sets, you want to prefetch, and you have a workflow where it takes everything in chunks, and you use Databricks or whatever your favorite multi-threaded parallel processing software of choice, things like that.
This is really interesting. You can do a lot with all these data sets. Oh, that reminds me something. I mean, I don't know why it reminds me, but somebody said last week that they talked about the new Apple M1 chip that is coming, that actually came out last week. I think it was Mehul, or maybe Mayank. I'm not sure which one of you. Yeah. So I'm in a situation right now where I'm getting a laptop, and I'm being forced to get an Apple laptop, although I don't like Apple laptops. And so I'm thinking, well, maybe I should make them get me an Apple laptop with an M1 chip in it instead of the normal MacBook Pro.
You get a job at Google or something? They're forcing you?
Not at Google, right? But yeah, they like the Apple ecosystem, and everybody has to use it. So, but then I started to poke around, and I found out that this new M1 chip isn't even guaranteed to play nice with machine learning libraries like TensorFlow and PyTorch. They say, oh, it's coming. We're working on it. So that's enough. Just knowing that is enough to tell me, no, I don't want to try this M1 chip because you can't do any machine learning with it.
If somebody else is paying for it, you might as well get the previous generation without the M1 chip.
Yeah.
But ask for what I did, 64 gigs of RAM.
Okay, that's a good idea. I think I only get 16.
Insist on 64.
Insist on 64. Okay, I'll remember that.
I
might have to pay for. Yeah. I might have to pay for the 64 out of my own pocket, but we'll see.
Just to add, I think so. You can go for M1 too, because it's 15x faster, 15 times faster than the Intel's chip.
And but I don't have use for. I don't do gaming or anything, and that's really the main application where you'll see all that speed, I guess.
If you're going for a complete data science ecosystem, then go for Windows and then take an NVIDIA chip. That will serve all your needs.
Exactly, and they don't have, and the M1 chip doesn't do what the NVIDIA chip does. It's not a replacement for the NVIDIA chip yet. I know they're working on that, but they just tell you to be patient and we'll get it. But I'm not buying an M1 just on that. And plus, they only have I think right now you can only get 8 gigs of RAM and 8 gigs of GPU. So that's the
max
limit.
Is in Indian subcontinent, the max is 16 gigs. RAM.
That's right. You can get 16 RAM, but you can still only get 8 of GPU, right?
No. The GPU with respect to the M1, if we talk about, it's integrated. So it has the shared memory. So with respect to your cores, high performance, low performance, your neural engine, and all of that stuff.
So that's why they say that the neural engine has 16 GB, because it's accessing a pool of RAM that is used for both CPU and GPU. Is that?
No, it's not six. No, it's not 16 GB. It's you can think of it as a subsection of the whole SoC, the whole system of chip that has been dedicated to neural processing, and those number of parallel cores are specifically designed for designed to replicate or simulate those NVIDIA's CUDA cores. So that kind of parallel processing can be done faster.
I see. Yeah, I think there's another company called GraphCore that has done something like this. They completely rethought the whole concept of the chip, and so that all of I know that Srinivas probably will understand this much better than I do, but they've redesigned the concept of the chip so that the data moves faster and everything is on the same, the memory and the I forget how it works, but there's new ideas about how you design chips that integrate CPU and GPU and make everything work faster. Apparently, the old chips didn't take into account that they were going to be working with GPU, so you have to transport data off the chip, transport data back and forth and so on. And with an sort of an integrated environment, you save a lot of processing time and also heat, by having it all done on the same chip. Srinivas, do you know anything about that, like the graph cores?
There's just quite a number of startups now, but it's a whole, that can take study group by itself of how do you change the architecture of basic CPU and GPUs and collapse them even at a instruction set level in order to eliminate and or data transfer, because processing is incredibly fast, which is why GPUs are fast, but all the data shuffling is where it takes a long time. And obviously, if you can shuffle data within the chip, it's incredibly fast as well because of the distance within the chip, although that's also growing. But the latency things I posted, I think last week or something, gives you an idea that any access that you do outside of the chip, so for example, outside of the caches, and now they have multiple levels of cache, blah, blah, blah. But the hardware world is changing, and it obviously doesn't change at the speed at which software can change. But I think that the transition will come. There are a lot of startups and it's a lot of integration going on of how best to combine these concepts of having to shuffle data from a C as in central processing unit to a G as in general or graphic processing unit. And there's a lot of additional overhead in graphics because it was originally designed, if you recall, to do graphics processing.
Yeah.
So there's texture overhead and other things that you don't need when you just do ML and AI. So, but it's easier to change the hardware. It's harder, much harder to change the entire ecosystem that's been built on top. So it'll take several years to get there.
Yeah, and the hallmarks of this new kind of architecture are what we see claimed for the M1, which is a much faster speed because of they've eliminated all the shuffling, a lot of the shuffling that has to be done back and forth, and also much less power consumption because shuffling data across wires generates heat and so on, wastes power. So those are the two hallmarks: are reduced power requirements and faster speed. So
just to add to that, there's also it's just changing so much. Like last couple of Kaggle competitions, like for the large data sets especially, we've just moved up. Like most, one, I think the melanoma one, the medical one. This person, he showed us, there's one Kaggle grandmaster, he showed us how to use the TPUs, since Kaggle provides like 40 hours of free TPUs, and I would say like there were maybe 4,000 participants, maybe half of us just stopped using GPUs for that one. We just we just all moved to the TPUs. It is, I even rented, I rented 4 GPUs, like 4 really good GPUs. I think 4 V100s, and the TPU was just better. So there's a lot of that coming. So it's hard to know exactly, I don't even, I don't see myself doing like any processing on my laptop anymore. Like either Colab or Kaggle or whatever else is next.
yeah, I mean that's like last year I bought a nice machine with an RTX 27, nice laptop with an RTX 2070 on it, and I really haven't needed to use it because either the code that either I can't, because it's a Windows machine, a lot of code doesn't work on Windows, so I'm forced to use the Colab. And then it's just become so easy to use Colab, especially if you get a Colab Plus account, you can have access to the TPUs. So, it's kind of a waste. I bought this laptop and I don't really need it, all the processing power that it has.
For the GPU versus TPU experience, is TPU faster just for TensorFlow, or is it like in general faster?
I think you can run it on PyTorch, right? Am I not? Can somebody correct me if I'm wrong?
I think they were.
Yes, you can.
Okay.
Yeah. And does anybody know the difference between a TPU and a GPU? I know Srinivas was saying that GPUs do a lot of graphics intensive things that you don't need for machine learning. So is that what the TPU does? Is it cuts out all of that? Or I don't really understand the difference between a TPU and a GPU.
No, I don't. It's yeah. It was confusing. I was able to use it, but I didn't understand all the details. Like they say something about it's one TPU, but it has 8 cores or something. But it has the biggest difference for me was it had a lot of RAM. So it's like there were 3 versions. Like they had 64 GB RAM or 128 GB RAM compared to like say 16 GB on the GPU. So my batch sizes were much bigger on the TPUs.
Oh, yeah.
But that's just
Yeah.
a very I don't know much about
Yeah,
TPUs.
there are papers and there are multiple versions. I think by now Google is on version 3 and there are papers in the architecture conference. But yes, the short answer is, because it's constructed from the bottom up to support tensors, it's much more fine tuned to doing what ML AI workloads do rather than repurposed from graphics to support large matrix multiplication like operations, which were the basis for a lot of um, not tensors, but a lot of graphics processing. I forget the specific terms we used to use for texture mapping was the basic capability that GPUs originally supported, repurposed to support MLAI, but TPUs are built from the ground up to support
Shaders. Yeah.
tensors. So I think given that, yeah, a lot of customization and GPU and Google has also done it a lot less than Intel with so many generations, but they are on their 3rd generation now. So they've learned a lot as they did the 1st and the 2nd.
So who builds these TPUs? Is it just Google now, or are there other companies involved?
Amazon has its own effort, but I don't know that I've seen results of it deployed yet. But so far, the tensor processing units out in deployment are from Google.
Let me just echo everything Srinivas just said. In the business world, a lot of these investments, technology investments, are going towards, for the hardware side, there is a lot of focus for this, and it's going towards very specific chipsets by purpose. So exactly as Google went to TPUs, which are GPUs optimized for machine learning, as opposed to exactly as Srinivas said, repurposing chips that are used for graphics. That's exactly what Apple did with the M1 chip. And there are other entities that are also building their own very specific chips. If you look at Tesla, they have an effort there as well. The idea of virtual chips, FPGAs, and so on, that is become a very, very big deal in finance. And so on. The one thing I do want to just at least sort of stepping back a little, for those folks who have Windows machines but want the same kind of machine learning experience that Mac with their Unix backend have, please take a look at Commander, CMDR. It's a freeware tool. I believe it's sort of like it's a terminal emulator that takes Windows and recreates and emulates a Linux environment. Once you have that, you can now run a standard Python ecosystem that you can have, the same thing that'll run on Linux or Mac or on Commander emulated Windows as well. Just a tip. It's something that is done for major organizations.
I thought Windows now has the version that allows you to access Linux.
Are you thinking of PowerShell?
Because WSL.
WSL, yeah.
Yeah, WSL.
Windows. Yeah, I have tried it. I have used CUDA and TensorFlow on it. It's fine, but it's not worth your time.
Really? Okay.
Yeah, because you will have to go to the dev version of the Windows. It will be very unstable. It will crash often, and there it's still in the dev mode. So you can, if you try, but it's not worth the hassle. Instead, just use Ubuntu on your laptop, and
Use what?
you'll
Use
Ubuntu.
what?
Ubuntu.
Open
Just create
to?
another Ubuntu flavor of
Oh,
Linux.
Ubuntu. Yeah.
Yeah, on your laptop, on reinstall everything, clear out Windows. If you are specifically targeting ML workloads, because I have a couple of machines at my home to for the work I do, and one is totally server with respect to Ubuntu, and the my machine learning workloads, they totally run on that, and my other one is my home or HTPC, in which I can stream videos and that, because Windows will give you a much higher bit rate and the graphics quality if you are trying to play games or
Yeah.
stream Netflix.
So you can install Ubuntu under Windows 10. Is that what you're saying?
With a virtual
Yeah.
machine, you could get the licensed VMware or Parallels, or you can get the freeware version, which works just as fine.
Yeah.
But if you are trying to pass on your GPU now, so that won't work. So if you have a single GPU and you have parallels or a virtual machine, and you have to use your GPU inside that virtual workstation, that won't work. Instead, a specific version of Windows Dev with WSL2 might work. I have tried it. It works, but as I said earlier, it's not worth the hassle. It's very much unstable.
Well, that's the only reason why I would want, I'd want to be able to use the GPU on my Windows laptop. And that's what WSL2 promised, that now you can use your GPU, but I guess they really haven't straightened it out yet, or.
Typical Microsoft, always create something that's sort of dipping their toes in the water to say, yeah, we have that solution, but not really.
So,
true.
Yeah, sorry, go ahead, Mayank.
Because I've tried all of this when WSL2 came out a couple of months back, and still if you go at the open forums, there are still people rambling about those open issues, and their RTX GPUs are still not compatible with the latest versions of Windows and the operating system and WSL2. So that's still an ongoing debate, and they are still working on it. So.
Well, so Mash, you were talking about this commander thing. I have it on the screen, right? Do you see it?
Yep, that's the one.
Yeah. So how do you use this, and can this allow you to access your GPU from a Windows 10 machine?
If you configure your Python shell and to run off of the GPU, then the answer is yes. I don't know how to do that because I'm not a software engineer. You may need to fiddle around and Google, see if somebody has done it. But if it can be done on Windows, it can be done on Windows. This is what you will use. That's all.
Are you accessing a Linux environment from this interface, or?
No, it emulates a Linux-like environment, and it runs Python, and so this is what I would use for my work machine that I no longer have. For the entire Python ecosystem with all the standard packages and so on which the solutions would be built. So if you're a data scientist who works with Windows in a highly protected environment, Windows would need Commander. Then from this, you can install your Python and all of the supporting packages.
Oh, I see. So you're saying this is like if you're in a corporate environment where they strictly control what you can do with Windows 10, this allows you to get around that and install
Right,
Python
but
and do all your.
right, but but with this, you're not using Python with within the Windows shell. You're doing it within a Linux-like emulated shell.
So you can install Anaconda, for example.
Bingo. Correct.
Okay.
Correct. You can create your Conda environments and so on within this. Makes it a lot easier to work with, and very similar to if you have, you're trying to keep some standards with people. Half your people are using Macs, the other half are using Windows. You want to make sure they both are using the same versions of individual packages and so on. Maintaining standards is absolutely essential when you're a large organization.
Well, I guess, yeah, so this would solve that problem. Whereas if you have your own laptop and you can control things, I guess it's just as easy to use the Windows 10 environment. You can install Anaconda and build Conda environments and all that, just as you can on Linux. I guess the only difference is you can't access your GPU. I don't think but this commander probably doesn't allow you to either. I guess it's something they have to fix in the WSL2 API or something like that.
So if I had to solve this problem now, what I would try is I would try to see if I can use Docker to have Ubuntu image to access GPU. I don't know if it works.
It doesn't.
But
yeah, okay. I mean, it would be nice. I mean, that's I tried to do that some time ago, and so far as I know, it doesn't. It's nice, but it doesn't allow you to use your GPU. So anyway,
so what I did is so I have a laptop with GPU, which I don't recommend because it overheats. But what I did is I created like USB stick that allows you to put Ubuntu distribution, and basically I did dual boot Ubuntu.
Yeah.
But it's a very tricky thing to do with Windows 10 because especially like latest version, you have to go like, and it depends on what manufacturer the system is from. You have to go and mess with memory. So actually on my latest laptop, I successfully killed Windows. So I don't have dual boot anymore.
So you killed Windows and you killed Windows and you just have a Linux machine?
Yeah. That wasn't my intention, but you know.
Well, I thought I could do dual. Yeah, I tried to do a dual boot system once, but then practically it just I couldn't make it work for me because you can't the file you have to maintain two separate file systems, right? So if you load data, if you download a data set on your Windows machine, you can't see it on your Linux machine.
Well, that's why you get you can get commercial software. For my Mac, I have Parallels, $100 a month. I'm sorry, $100 a year or so. Or you can get VMware, which is about 150 or $200 a year. And you can run as many virtual machines as you like. So I have my own personal Windows virtual machine on my Mac. I can create other Windows virtual machines as I need for different Windows specific projects. Same with Linux, et cetera, et cetera. As you know, you can have 100 different virtual machines running on your Windows or Apple MacBook.
Can they all see the same file system?
They can all see the same file system if you so choose.
That's very nice.
Well, Parallels does what's called Confluence. It's a feature they have called Confluence that integrates your virtual machines with the native operating system, the primary operating system. So it's the same. It can share all of your files and so on. Just be careful with security when you're doing things like that, file level security. But yeah.
What about sharing the GPU?
That's the big question. Yeah, you guys, I don't know how that is done. I'm eager to hear everyone's experience. I know one of you, said that you're just using your own virtual machine with a GPU with 4 GPUs attached, like a Tesla T100. And I think you had shared 2 class sessions ago how you were just running your code connected to that GPU virtual machine, but you were basically working with it on your own personal machine, just sort of passing the jobs to the GPU VM. I think that may be the right way to go for now, until we can integrate everything.
So does Apple, like an Apple MacBook Pro, do they have access to it? Do they have an NVIDIA chip, or can they access GPUs?
No, there is a couple of years ago, Apple used to have this. You would connect this GPU container. It was like a basic NVIDIA chipset, and you could connect that and do some intensive graphics work. And the idea was you should have been able to do machine learning with that too. I don't think anybody really ever got it to work. It was like an extra
external GPU.
Yeah, it's an external GPU. And even for $800, it's not worth getting that just to kind of try out. And I don't think most people do that. If you really need a GPU-based machine, chances are either you're going to use Google Colab or Kaggle kernels, or your employer is going to pay for an AWS or Azure virtual machine connected to GPU.
Yeah, I guess that really hit me as a shock when someone said, I think it was Mehul said that it's really, you really are going to eventually do all your machine learning stuff on the cloud, so you don't need to have that on your home machine.
Yeah.
So that makes sense.
I agree with the production version. Suppose when you're trying to productionize a particular end-to-end machine learning pipeline, you will be required to do everything in the cloud. But I disagree with the points of research. If you're trying to implement some sort of novice or you're trying to experiment or play with some parameters now with respect to some optimizers or regularizers or some research in like my area, which I'm trying to go ahead in reinforcement learning. So there those small minute changes with respect to elevation studies, if I'm using the term correctly here, that affects on how those small tweaks totally impact your whole pipeline. And when you're trying to from my perspective, I try to firstly perform those experiments on those local GPU that I have. I currently have an RTX 2070, and then if required, I can scale it in the cloud, and on the basis of TensorFlow's production APIs or PyTorches or whatever is available. So that's my area of
So to access your RTX 2070 GPU, you're using a Linux. You're just using you're accessing it through Linux. I see. So you have a Windows machine and it's dual boot, or you just made it into a Linux machine?
No, I have two machines. One is the HTBC one for gaming and streaming, and the other one is totally for work, the ML one. So that's totally an Ubuntu one.
Oh, okay, got it.
Yeah, with 2070.
At work, for local development, we are still doing. We have a machine at work too. We just bought a Dell machine with two RTX 2080 and just dual boot, dual boot Ubuntu 20, and took. I think we made a mistake. We didn't get enough SSD, so we put maybe 60% of the SSD for the deep learning machine and or something like that, right? Yeah. But dual boot has been like fine. We've been running it for like a year, and it's I yeah, the files, the sharing. I think you can do mounted folders or something. I can ask around. But mostly for getting data, I just use wget or like some rsync or something to get the data. So I haven't had I haven't had a use case where I have to download the data on Windows first and then move it to the VM. So we just been um, like running dual boot, and it's been fine. Yeah.
So you can work on your home machine on your own machine for a lot of that, for a lot of your work.
Yeah, it's in the office. Yeah, so it's.
I see. So Ubuntu is the way to go, I guess. Okay, so are there any other comments at this point? I guess I still haven't I haven't looked at the I haven't looked at with you the chapter 13 notebook, but I ran through it and with a few glitches it actually runs, and but it's a very long notebook, so I think in the next 10 minutes we can't do much.
How did you fix the person problem?
Where are we talking about?
If you go up.
Okay, here's the start. And then I noticed this thing: you can safely ignore package incompatibility errors, of which there are many. See, it gives you all these errors, but they don't matter in the long run, except for this one. I think it wants pandas 1.1, and most people, I don't have it. I guess in the environment which this is run, only pandas 0.25 is there. So it's what I did to fix that was I just installed the latest version of pandas somewhere. I just did a pip install somewhere down the line here. But you were talking about a person problem, or which one was that?
The section of protocol buffers that failed.
Oh, that's way down. Okay, let's have a look at that. That's way down. Let me just look for, let me do a search. Oh, I can't be doing that. Let's see. Find in this page.
That section.
Okay, there we go. Brief intro to, okay, so you install protobuf, person. So is there somewhere in here that it failed for you, or?
It was when you import the protocol buffer, the PB2. So if you scroll down right there, number 75, cell 75.
From okay.
That, for me, it failed. And I couldn't figure out how to get past that. If anybody had the same issue, if not, then I'll chalk it up to my machine or my setup.
Yeah, I think I saw that the 73.
Yeah.
That will error for you. It will say can't find a proto C.
Yep.
And that probably you need to pip install proto C, and then it will work. Yeah.
Got it.
Okay, there you go. Yeah, because see, when I execute this and then I look for what's there, it actually has these files, so it won't throw an error when you ask it to import something from person PB2 because it's there.
Yep. Proto-C is a compiler that needs to be installed on your local machine. Then, to compile it. Yeah.
Where is that actually done?
This on the line 73. Yeah.
Oh, is it this one?
Yeah. Here we are executing it. This Proto-C with the person.protofile, and these are the various flags that we give. Double.
But this assumes that Proto-C is already installed. So do you have to do some kind of pip install Proto-C or something?
Just scroll a bit above.
Yeah. I missed
install
that. Install protobuf right there.
Yeah.
The first
install
one.
protobuf. Okay.
That's
a
my problem.
hyperlink. Yeah.
Oh, okay. So this tells you how to do it, but it says in general, you will not have to do so when using TensorFlow as it comes with functions, blah, 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 which are generally sufficient. We need the proto-C. So I guess you have to go to here. Let's see.
Just a quick note. For my Windows machine, I had to install it based on a package manager that it provides. So I firstly installed a package manager, and then there's a Proto-C uh, command there uh, for this compiler. And yeah, you can.
So you had to go here. Is this place you had to go to get the
That's
to
where
this
it is.
GitHub? Okay.
Yeah.
I see. I didn't have to do it, so I'm not sure why. And I'm on a Windows machine, so yeah, I'm not sure why I didn't have to do it.
I wonder if it's because you're running it on your collab while I'm.
That's right. It's not on my personal machine. Yeah, that's right. That's
Yeah.
right. Not on my Windows machine. Any other places where you had some rough?
No, everything I had resulted from this error.
Oh, okay. And then there were errors thrown sometimes when using pandas, but those errors were not important. You could just proceed, and it wouldn't and it wouldn't affect anything. So I forget what.
And there were a couple of errors with respect to the data types that they use in the protobuf format when with the image and labels. There, for example, in the exercises section, and there's a create example method, and there
Okay,
they had.
hold on for a sec. We'll go there in a sec, but I just wanted to call attention. This is what I'm talking about. Pandas, through this error, said it can't find, cannot import name is URL, but it didn't matter. It still was able to read the file. So that's what I mean. There's some errors thrown by pandas, but they're not important. You can still keep going. Anyway, Mayank was telling us about something down in the homework section. Which was it? Was it number 9 or number 10?
It was exercise number 9.
Number 9.
Exercise number 9. Create example method. Def create example.
There's 10. Okay, so there's 9. Okay, create
example. You can control F and yeah, this was the one. Yeah, here.
Is this it?
Create example. I think so. You scrolled a bit down. This is.
I need to scroll down some.
Only just a bit above.
Above. Okay.
If you scroll a bit up.
There it is. Create example. Is that it right there?
Create example method. Yeah.
So there was an error thrown, or?
Yeah, there was an error thrown in it, in which you had to convert the labels into the NumPy version, because it won't accept, the normal.
They're in a dictionary now, right? They come in as a dictionary, right?
So
and maybe.
So here the problem occurred with respect to trying to change the data type of the label. It originally the protobuf on label takes it as, I think so, int 64, and you had to convert it into tf.uint8 or something.
Oh, okay.
So just you need to just call a method as it's done in the above statement with respect to image data dot numpy. So just call label dot numpy, and that will take care of the conversion of that.
Here, image data.numpy, and you have to do image label.numpy. Is that?
No, just label.numpy.
Label.numpy. Because you're saying it comes in as a
Eager tensor, yeah.
Okay, it comes in as an eager tensor, but you're saying you have to convert it to something, right?
Yeah, we have to convert it to this compatible values, this NumPy compatible value to print it, or I think so, with respect to in the following sections, with respect to TF records
Okay,
or
so this might
something.
be
Yeah.
it might be saying eager tensor because I've already run these lines and it made the
Okay.
conversion. But maybe originally you're saying it was a NumPy and you need to convert it to a tensor.
No, it is in the int64 format, and we need to convert it into a NumPy. So that's the issue.
Okay. So that's where you had the trouble right here. But
Yep.
somehow so that's on your Windows or on your native machine, on your own machine, right?
Yeah.
Okay.
So yeah, but I don't think so. You had this
I
when
didn't
you
have that
ran.
problem. No, it
Oh,
ran. It ran.
okay, cool then. It might be related to a particular platform. So
Okay.
because Colab is also in the Linux environment, so yeah, so there might not be any compatibility issues there.
I see.
Yeah.
Okay, well, we're at the end now, but I wanted to have a look at our schedule for the rest of the class. So here's where we are. We just finished chapter 13. So this is today. And then a lot of people who had signed up to help with the class have left the class. And so I can't remember whether Salim is still going to give the reviews. I think he's might have said that he's still going to, even though he's not following the class right now. And Alvaro, I think you're here. You're doing chapter 19, and I could use some help if anybody wants to. It's not necessary, but the only thing is I want to do chapter 17 and I want to do chapter 18. But anything else, there are a few chapters between there. There's 14 and 15 that anybody else that wants to. I know Gautam's going to help with 16. But anybody that wants to help with 14 and or 15 is welcome to. If no one has the time, that's fine, I'll do it. But I could use the help if someone wants to.
Yep, I can.
Or you can, Mayank?
Yeah.
You want to do 14 and 15 or just 14?
Yep. I can do 14 and 15 as well.
Okay.
Yeah. Whatever. Yeah.
Okay. Well, I'll just put you in for that then.
Joseph and Mayak, thank you. Those are going to be important chapters.
Yeah, we definitely want to get through this. It looks like we're going to be at it until March, I think, until the end of February, I think. Let's see, what does it do? It goes to, yeah, March. Salim, if Salim does this full book recap, it'll be March 3rd. If he doesn't, it'll be mid-February when we'll be done. Okay, well, I'll finish editing this. You don't have to watch me do that. But thank you.